Hello, everyone. Good afternoon, good morning, good evening, based on your location. We hope you've had a good day and you, as well as your family and loved ones, are doing well. On behalf of AIOUG, I would like to welcome you all to our weekly webinar series. For those of you who are joining us for the first time today, AIOUG is an All India Oracle Users Group, and we conduct our knowledge sharing webinars every Wednesday, where we're trying to bring experts from all over the globe to help our community learn and grow. And so today we are extremely thrilled to have Christian and Togini from Zurich, Switzerland here with us today to talk about shareable cursors and how to use them efficiently to make our lives easier. Chris is a proud member of the elusive Oak Table Network, an Oracle Ace director, and author. You've probably come across his books in performance tuning, and currently works as a principal consultant and trainer at Trividas. His main interests include logical and physical database design, query optimizers, and basically everything that is related to data processing and application performance management. Again, we are really excited to have Chris with here today. Now, before I hand off to Chris, I do wanted to remind you a few things. The presentation will be shared with the attendees. For all your questions, there's a Q&A panel at the bottom of your screen. Please use that, and we will take the questions during the Q&A time. Again, we request you to take a virtual selfie and tweet about it. This is pretty important so that we can thank Chris for his time. So you can see the hashtags on your screen and on your screen. So use those hashtags and take a minute of your time and thank Chris. Again, this is a notification. This is a information for people who have attended all our webinars for a month. Please reach out to us if you want to get a certification of participation. So with that, I think we're good to begin. Chris, could you kindly share your screen and take over?
Hello, everyone. Yes, let me do it. Okay.
You can see your screen now.
So, should be set. I must immediately apologize because I don't know why the video is constantly freezing. So it's not that I'm not moving or not speaking, but it's really kind of annoying because I mean, I have, as far as I can say, set up everything correctly, but it doesn't work. Anyway, I would say it's not such a big deal if you don't see me more. So hello, everyone, and thank you very much for joining this session. And of course, thank you very much to the organizers to inviting me and to organize these webinars series. As mentioned, my name is Christian Antonini. I'm based in Switzerland, and today I will talk about shareable cursor. I must immediately say that shareable cursor is not, or I mean, the content of this presentation, it's, I would say, nothing really new. I started doing this presentation more than 10 years ago, as far as I remember, and the content didn't change much over time. But I keep doing it on a regular basis because I see plenty of people that still struggle to really understand cursors with Oracle database. So even though, again, it's nothing new in the latest Oracle database, I think it's information which is very important to know if you are dealing with performance problem. In general, if you have performance problem and you have to troubleshoot them, it's very important to understand how the database engine works, and cursors are part of it. Okay, I will skip my introduction because it was already done. Quickly about the content. Of course, I will start covering what a cursor is. Okay. Then we will talk about private and shared SQL area. What are the differences between the two and what they contain? Then we will talk about what is a parent, what is a child cursor, and again, what is the difference between the two. Then once basically it is basic information about cursor is over, we can talk about bind variables, graduation and peaking, and some additional optimization that are available in Oracle database, like adaptive cursor sharing and statistic feedback. Okay, so that's about what to expect over the next 60 minutes. I will try to do as many demos as possible just to show you what I'm talking about, because in my opinion, it's always easier to understand something if you see it live. Okay. So let's start with the first key question on the contents agenda slide. What is a cursor? Okay. If you try to define what a cursor is or answer this question, you can say that a cursor and all the associated structure, it's what you get when your application execute a parse call. You want to execute a statement, so at some point you have to parse it. Later on you execute it, and then you close it, basically. And when you execute a parse call, you get a number of structure in place to let your application execute that SQL statement. But it's what is a cursor? If I have to define it in one sentence, I would say that the cursor is a handle, and a handle is basically a memory structure that gives you access to another structure, memory structure. And in this case, it's a handle to a private SQL area with an associated shared SQL area. Okay, and we try to get a picture of this. We can see that I have the client memory. Doesn't matter where the client is running. I am on a specific computer. This computer has a piece of memory, and in memory you have the handle. Okay, and the cursor actually, technically, I will say it's this handle. There's not anything else. Okay, so this handle allows you, as I said before, it's a memory structure that gives you access to another piece of information. In this case, it gives you access to the private SQL area that is in the memory of the server process to which you attach once you connect to the database. Now remember, every time you connect to an Oracle database, you have a server process on the database server that works for you. And in this server process, you have some private SQL area, you have some memory, and in this memory, you have some private SQL, what is called the private SQL area. Okay, so the ender points to this private SQL area. And in its turn, the private SQL area points to a shared SQL area. And the shared SQL area is not specific to every process, but it's shared in the SGA, in the library cache. Okay, and the idea is really that you have some parts of a cursor that can be shared, okay, among many sessions. So you put this part in the shared SQL area. Some parts are private, so you put them in the server process belonging to a specific connection. Okay, and the handle, so at the end it's the cursor, gives you access to all these structures. Okay, but let's have a look more in detail to the private and shared SQL areas, what they contain, basically. So the private SQL area is, again, private to a specific session, okay? So it contains data that cannot be shared with anybody else. Like if you have a statement with bind variables, then the value of this bind variable must be there. If you are executing a statement, which is the state of the execution, for example, if it's a query, you are retrieving data from the server. So that's where Oracle stores the information. Okay, it is the the cursor open, I already start fetching data, and so on. So all state-related information are there, and these are private. And again, since they are private and session-specific, they are stored in what Oracle calls the UGA, which is specific to one single user. Okay, or best not user, but one specific connection to the database. From the other side, the shared SQL area contains, of course, everything that can be shared. So if you have the parse tree of the SQL statement to be executed, the execution plan, and all the associated stuff that are in the SGA. So this is the shared SQL area part. And since it's shared, again, it's in the SGA, it's stored in the library cache. Okay. And what is important to say that even though I said before that the term cursor actually should be seen as the handle on the client, in practice, when we say cursor, we mean more or less all the structure I mentioned up to now. So we mean the handle, the private, and the shared SQL area. So we are not, let's say, picky to say, if you say cursor, it's only the handle. But when we say a cursor in general, we think about all the structure that let you execute a given SQL statement. Okay. Now, if we go more a bit more in detail in the shared SQL area, there are two additional, can say, objects or structure. One is called the parent cursor, and the second is called the child cursor. So the next thing we look at is what is a parent and what is a child cursor. So let's start with the parent. And I must say, parent and child cursor contains plenty of information, and here I will describe only the key information you have to be aware of. Other stuff like statistics and so on is not very critical, but the key information stored in the parent cursor is the text of the SQL statement on which it is based. Okay, that's the key part of the parent cursor. Okay, so let's have a look to that with a small demo. Okay, what's going on here? The rest of my session is no longer. So I lost connection. Just a second, restart session. Okay. What's going on here? Oh, yeah. Sorry about that. Of course, I tested everything before the start, and it seems like a virtual machine just crashed. Let me restart it. And we'll just take a moment. Let me go back quickly to the slides while we are waiting for the start. So I was saying that the parent cursor contains the text of the SQL statement. And what is important to see is that several SQL statements can share the same parent cursor only if the text is identical. This is a very important piece of information. So if you have an application, you have a number of clients, and everyone is executing exactly the same SQL statement, the point is that all of them can share exactly the same parent cursor. And that will reduce the amount of memory you have to have on the server to be able to execute it. So let me try to restart the session. Okay. Start two databases that I will use during this demonstration. Why two? It's simply because for some demo I need a specific environment, so I put one of them in a 18 database, the other one in a 19 database, but it's not, let's say, very important. Okay, the first was started. In the meantime, do we have questions? Not, okay. So the first one is the shareable parent cursor. Okay, sorry about that. So in all my scripts, I just create a small table at the beginning, gather stats. I would say nothing really relevant. It's just to set up the environment. Now, what I'm doing here, as you can see, I just execute several queries. If you check the text of this query, basically, you can say that they do exactly the same thing, okay? But as you see, sometimes I use uppercase, sometimes lower. Here I put some spaces. Here I added a 0 in front of the 1, 2, 3, 4 value and so on. And the point is, based on what I said to you before, okay, that it's possible to share a parent cursor only when the statements are identical. That means that for this SQL statement, we cannot use the same parent cursor as for this one. And the same thing applies to the third one. From the other side, for the fourth one, we can use the same parent cursor as the first one because it's exactly the same text. And for the fifth one, again, we need another parent cursor. Now, if we check in memory what parent cursor are available, and if you want to know which parent cursor exists, the view you have to query is $SQL area. Okay, you can see that we have 4 parent cursor. One of them executed 2 times, and it's the one that was executed first and the fourth one. Okay, that's the first important information here to recognize. The second one is that to identify content in $SQL area, you use the SQL ID. The SQL ID is simply a you can think about it as a hash value of the text of the SQL statement. Okay, so if the text is exactly the same, the hash value will be identical and the SQL ID will be identical as well. Okay, so to identify a parent cursor in $SQL area, you need the SQL ID. Of course, if you are, for example, in rack, and you are selecting $SQL area, you also need, for example, the instance ID in addition. But let's say keeping rack outside of this discussion, it's enough, this information. Okay. Now, an exception to what I just mentioned, that the text must be identical, is when you have cursor sharing set to a value which is not exact. Exact is the default value, which means basically the text must be exactly the same. Okay, and if you set it to false, the only other value which is allowed or supported in current version, then what you can see is that even though you execute a number of statements that are different, or where the difference is only a value, like in this case, you see 1001, 2001, and 3001, okay, What does Oracle when cursor sharing is activated will remove or replace these values with bind variables. And so you can increase the shareability, if you want to say like that, of the parent cursor. So in this case, what happens is that Oracle creates two parent cursor, one for the first 3 statements, because once you replace, as you see below, the value with a bind variable, the statement are exactly the same. From the other side, the 4th one, since it's written lowercase, cannot share the same parent cursor, and so you get a second parent. Okay, it is important here to recognize that one, let's say, or one exception to the fact that text must be exactly the same is cursor sharing. Okay, that in some situation can be used to improve, to make more statement shareable. As mentioned during the demo, where to find parent cursor with $SQL area and how to identify them in general, SQL ID. Okay. Now that we have seen the parent cursor, let's check the child cursors. Okay. The key information stored in child cursor are basically the execution plan, the information used by the database engine to know how to execute something, and the execution environment related to it. And that is very important. The execution environment is critical, not only the execution plan, because, for example, if you have 2 clients, one connected with some NLS parameter which are different from the other one, the execution environment are not compatible, and you might not also be able to use the same execution plan for both of them. Okay, so it's critical that the execution environment is exactly the same when sharing a child cursor. Okay, so as I just mentioned, to share the same child cursor, you have to be able to have a compatible execution environment. And in addition, since a child is always attached to a parent, you also have to be able to share the parent cursor. Mind you, that I'm not talking about at this stage that a child cursor, also 2 child cursors must always have a different execution plan. That is not important. Okay, Oracle doesn't generate a new child cursor because there is a new execution plan or the opposite, but it just check, can I share the parent cursor? Can I share the execution environment? If yes, it will share the child cursor. If not, it will generate another one. And if they end up having exactly the same execution plan, it doesn't matter. Okay. Also in this case, let's have a look to an example. So let's do the shareable child cursor demo. Again, I create a small table, not very important what it contains. Okay, what I want to show you here is that I execute basically the same SQL statement. As you can see, it's a simple select count star from T, okay, but with different optimizer modes. Okay. And as I mentioned before, since the text is exactly the same, Oracle will create a single parent cursor. But because we have different execution environments, we will need a different child cursor. Here I execute basically with every possible value of the optimizer mode parameter, even, let's say, no longer supported one like these 2. Okay. Now, if we check which child cursor exists, and you do that in $SQL, $SQL area, parent cursor, $SQL child cursor. And what we can see is that the SQL ID is always the same because the parent cursor can be shared. The text of this query is exactly the same every time. But since the environment is different, Oracle creates several child cursors. And what we can also see in VLORA-SQL is which optimizer mode was used. And so we can clearly say, okay, I have one child cursor for all the rows, one for first row, one for rule, and one for choose. And here something a bit special you see for first rows, even there are 5 execution. Why? Because I used the first row 1, first row 10, 100, 1000, and so on. And even though the execution environment, you can say it's different, Oracle in this case creates a single child cursor. It's a bit a kind of special case. Difficult to say if you have to consider it a bug or a feature, but it works like that for decades now. So I will say it will never change. Okay, but the point I'm making here is really the execution environment is not compatible or creates several child cursors. And if you check the hash value of the execution plan, okay, and the hash value is based on the structure of the execution plan. So if you have exactly the same hash value, you know you have exactly the same execution plan. So in this case, you can see we have 4 times the same execution plan. So it's not, as I said before, that Oracle creates a new child cursor because another execution
Guys, sorry for the interruption. I think Christian has got disconnected. We are trying to bring him back. Hi, Christian, you're back.
Hello, yeah, I'm really sorry.
No problem. You can let me just.
Out is morning. Morning for me. It's
okay. I think you can share your screen now.
It's not doing well. I had just now a blue screen and my computer restarted.
Oh, okay.
So something was definitely wrong from the beginning.
No problem.
Let me. Okay, let me share my screen. I'm really sorry about that, guys. But
yeah, we can see your screen now. Go ahead.
So can you just confirm that you can hear me?
Yeah, we can hear you well.
Can you see my screen, please?
Yes. Yes, we can see your screen.
Sorry. Okay, I should be back. Speakers. Okay. So I was talking about child cursor. I guess. Okay. QA is empty. Okay, just let me quickly restart instance as well as I did before. Okay. So we are talking about child cursor again. I'm really sorry about that. So I showed you that to be able to reuse a parent cursor, a child cursor, you need to be able to share the same parent cursor and they have a compatible execution environment. Okay, and if you're looking for child cursor, the view you have to query is with $SQL, and to identify something I didn't mention today, I didn't at the time. Basically, you need the SQL ID and the child number. The SQL ID will be the same because you are sharing the same parent cursor, and the child number is simply a numeric value which is incremented every time a new child cursor is used. Okay. Now I see that there is a question if there is any advice to not set it to false. I mean, if there is a problem if you set it to default in a database. I mean, the general advice about cursor sharing is to not set it, so to use exact. Okay. The parameter shareable cursor is basically there if you have an application that incorrectly doesn't use the bind variables and you want to increase the shareability of the cursor, then you can set it. But I will say it's always something you have to do when you have a problem. So by default, leave the parameter to its default value. Okay, cursor sharing equal exact. That's the default. And if you have a problem, you might consider set it to false. Okay. I hope that that it's answered. Okay. Okay. Another thing I wanted to show you, and yeah, I have to restart the demo because that is interesting. There is a view which is called with $SQL shared cursor. That shows you why a child cursor cannot be reused. That is a critical piece of information if you want to understand why something like that happens. Okay, so let me just start from where I was before. Let me set a decent font so you can. Okay. See what I'm doing and what I'm typing. Okay. It's no longer into child cursor. Okay. But that's the same demo that we have seen before. Okay, and there is the piece where everything crashed. Basically, when you have, excuse me, like in this case, several child cursors, and you want to know why do you have several child cursor for a specific statement, you can query with $SQL share cursor. You specify the SQL ID. In this case, it says, okay, I want to see all child cursor except the first one. And then what you get is a long list of flags. Okay. And basically what this flag means is that for every reason the Oracle database has, also can show you for not sharing a statement, they provide a flag here. So this thing is maybe not very readable, but you see there are a lot of no, so that means that's not the reason why it's not shared. And then at some point you have a yes. Okay. And of course, if you execute this query with a decent client where it shows you what the name of this column is, you might end up seeing the actual reason. And then in addition, in the recent version, they also added a reason code. And in the reason code, you have also some text in addition to it. So in this case, you can see the reason is optimizer mismatch. And remember, to get several child cursor, I change the optimizer mode. Okay, so that's the view to query. And in this case, I select only the specific flag I'm looking for. In this case, you can see, okay, the child 1, 2, and 3 were created because of an optimizer mode mismatch. Of course, in this case, we know it, but if you don't know why you have many child cursor, in some situation, you can get also thousands, okay? And you can query this view, this dynamic performance view to get information about it. And if you parse in detail this XML reason column that I showed briefly before, it has a specific structure. And so you could also extract information like, okay, child 0 has an optimizer mode of all rows, and the number 1 wanted first row, so a new one had to be created. The number 1 has a first row, and the number 2 requires a rule, and so on. So you get quite a lot of details in this view if you look at it in detail. Okay. I just saw a couple of questions. Let me ask. Okay, the next question is, what is the recommendation for optimizer mode? I would say also in this case, use the default value, except if you have very good reason to use the first row optimizer. And basically today, choose and rule are no longer supported, should no longer be used. So you have the choice between all rows or first row. We'll say all row does a good job in most of the situation. And the only advantage of first row is that it optimizes in situation where you execute queries, but you do not fetch all data from the cursor. If that's what you are doing, then maybe first row is interesting for you. But again, if you are fetching all data from a cursor in general, the all rows is what you need. There is another question. Let me check it. In my prod database, I see a huge number of child cursor for each parent cursor. How do I identify the reason for this? That's what I just mentioned. Go select $$ shared cursor, check which of these flags, as I show you in the demonstration. Let me close this window. Check which of these flags are set to yes, and that's the reason. Then you might be, because the documentation is not very good what each flag means, but in general, if you Google or if you go in my Oracle support, you should be able to find some information about it. Also notice that sometimes you have several flags set at the same time, okay? But basically, as what you question it is how to identify the problem, and that's basically this view. That's your best friend to do this kind of analysis. Okay, next slide. You have to be aware of the fact that the reason Oracle database doesn't support an infinite number of child cursors. Okay. After a specific number, the exact number depends on the database version. Oracle will do what they call obsolete apparent cursor, and so basically at some point it will be removed from the share pool, and so it will be displaced. This memory will be used for something else. So the number is controlled by undocumented initialization parameter, which is cursor obsolete threshold. Okay, as you can see on the slide, in 11.203, the version where it was introduced, the value was 100, so the maximum number of child cursor was 100. In 11.204 up to 12.102, it was increased to 1024. Okay, and in 12.2 and later version, because of multi-tenant, it was again increased to 8,192. So basically, in current database version, you can have up to 8,000 parent cursor, child cursor in a parent. And let me show you an example. So we have that I have here. So here I'm using a 19C database, but I set the value to 100 just to be able to have a shorter demo if you want, or being able to reproduce it, reproduce the demo without huge amount of memory. Huh? So you see I have 100 set. So what I'm doing, as always, create a small table with, in this case, basically almost no content. What I do is I use this PL/SQL block. I loop 100 times. And as you can see, I execute the same query 100 times, but before executing it, every time I set the optimizer index cost adjust to the value of this variable here. The idea is just that I create 100 different execution environments. So in this case, what we expect is 1 parent, 100 child. Okay. If we select $SQL area, we see, okay, we have 1 parent, of course, and you can see version count is set to 100. It means we have 100 child. We will select $SQL, we will see 100 child cursor. And notice that the cursor is not obsolete. That means it can be shared, it can be used. Okay, if somebody executes this query, the cursor is there and can be used. Now, in this case, I select $SQL just to check the child cursor. As you can see, we have 100 child cursor. Good. Now, let's execute 5 additional times the query with 5 additional execution environment. And remember, 100 is the limit I set with the parameter. So what Oracle will do in this case, since the old parent cursor reached the maximum, it will obsolete it and create a new one. So what you see now in $SQL area is 1 parent with only 5 child. But what is interesting, if we check the address, as you see, is E18 at the end. And if we take the address of the previous one, it was 2F0. So basically, it's a different parent cursor. Even though it has the same SQL ID, it's a different parent cursor. And interestingly, if we select $SQL, then we see the 100 obsoleted child cursor is obsolete is set to yes, and we see the 5 non-obsolete child cursor. And again, the address is different. And that shows you that shows you 2 things. One is the limit, as I mentioned, and that the child cursor will be obsolete. And the second thing is that you, if you reach this limit, the SQL ID is no longer usable to exactly identify a parent cursor, because like in this case, you have 2 different parent cursor. And in such a case, you need the address for it. It's a bit, it's a case that doesn't happen so often, I would say, but it might happen, so you must be aware of it. Notice that display cursor, depending on the version you are using, in 19C now it can show you the obsolete cursor, but previously it was not the case, and you could also have an error because of it. But that depends on the version you are using. Okay. So again, what is important, if you have several parent cursors with the same SQL ID, that's the address that should be used to identify the child cursor. Let me check the question, because there are 2. So the first question is having many child cursors for a SQL ID is a concern? I would say not really, but of course, as I just mentioned in the demo, you must be aware of it. And in not recent release, you might also have an error with a tool like DBMS Explain. So I'm not sure that depending what kind of tool you are using, maybe it's a tool that doesn't support this situation. But basically it works. I mean, it's not a problem per se. So another question is, does an obsolete threshold result increase the number of art parses? Yes, of course, because if you reach the threshold, of course, you need new parent cursor, and if you need a new parent cursor, you need, let's say, an art parse. So, but of course, if you are executing only soft parses, you will not generate new child cursor. So it's not necessarily a problem, but I have also a slide about that point. Let me provide some additional detail later on. There is another question. Is there a way I can keep track of bind variables being used internally in a cursor? Let's say cursor execute hundreds of time each time with a different bind variable. I can keep track of bind variable each time. That's not possible. Oracle has some views, we'll see later on, to check the content of bind variables, but it's just a sampling which is used. So the only way to really have all values of the bind variable would be to use something like SQL trace, and then in the trace file you get all the values you or your application use. Just another question. So in case you have the same table T in different schema for the same sequence, will it just create a child? Yes. If the text is exactly the same, for example, you have the same application running in several schemas, then you have the one parent cursor and a number of child cursor. So the library cache is only one, and so you can share stuff which are not related with each other. So part of the execution environment is also which objects are referenced in the statement, not only the name, but really the schema and so on. And if you think about multi-tenant, you have exactly the same issue if you have several PDBs having the same schemas. And in this case, you increase, let's say, there is an additional dimension. So you can have in one PDB several schema with the same objects, and in several PDBs copies of this schema. So, but you can always share a parent cursor and have a number of childs. What exactly reason for row locking contention? I'm sorry, I don't get the answer because it's out of context with what we are discussing. Maybe we can talk about it later on, but you should provide more information. It seems to me that this question is out of context. Okay, let's continue. One question that was asked was about if it's a problem with parsing and the obsolete threshold and so on. And here I have a slide about too many, or which I call too many child cursor. Because somebody could also ask, or somebody also asks, I have many child cursor, I want to investigate it. And here what I'm asking is it a problem to have too many child cursor or not? Because if Oracle is keeping a limit, you might expect that there is a problem, because if it wasn't problematic, they wouldn't put a limit, except maybe for memory utilization. Okay, so in fact, one time what I did, I wrote a blog post testing what it means if you have a lot of child cursor. And on this slide, you see at the bottom a link to the blog post, so you can go and execute the same test I did yourself. Everything is published there. But simply put, the result of this test can be depicted in this chart. What you see is that if the number of child cursor is increasing, and then of course the meaning is child cursor per parent, for a single parent, then the parse elapsed time for new child cursor increases. If I have a threshold of 100, as you can see, the parse time is basically constant. It's 1-2 milliseconds, something like that. So it doesn't matter because, of course, such a high number of child cursor doesn't exist. But if you have a threshold like the default at 8,000, then you can see that basically the parse time increase with the number of child cursor. That, of course, if you have an application which has a lot of child cursor and it parses a lot, might be a problem, because at the end, okay, if you have a lot of parse and you are using this a lot of parse going in the same parent cursor, you might get some concurrency issue. In new releases, basically, you will see some weights related to mutexes. Okay, because if you are parsing a cursor, I mean, adding a new child to a parent, you must have basically a shared lock, if you want, with a mutex on the parent, because of course it cannot disappear while you are adding it. Okay, so be careful. A lot of child cursor in one parent can be a problem. Okay, and since, as I mentioned before, in 12.2 Oracle increased the number from 1,000 to 8,000, what we noticed by a number of our customers is that we had to change the cursor obsolete threshold to a lower value. For example, after an upgrade from 12.1 to 12.2, this value was increased, and if you have a system with a lot of childs, might get some additional problem. And on this slide, I linked a Moss note where also Oracle suggests you in some situation you have to decrease, or you can decrease the cursor obsolete threshold. Okay, so that's something that can happen. In general, the problem is that the application is it parses too much, so maybe not correctly written, but if it happens and you are upgrading a database, you might need to set this value to a lower value. Notice that Oracle increased this value because of multi-tenant. So for example, if you're not using multi-tenant, basically there is no issue at using the 12.1 default in 12.2 or later. Okay. Oh, good. I see a number of questions. Let's go back to them. How to avoid a high version count. It's difficult to say how to avoid it. It really depends on the reason. Because, yeah, it really depends on the reason. You have to check the reason code, and then depending on what the reason is, you might need to fix the app, you might change something on the database, you might not change it at all. So it really depends on the situation. Another question, what happens when the child cursor crosses the threshold? Basically what I mentioned before, if I go back to, let me say, answer live, done. If we go back to demonstration here, we had a parent with 100 childs. Okay, here 100 childs, then created or requested a few more childs, but since we crossed the limits, then the system obsoleted the old parent cursor and all the children attached to it. Okay, so the point is that Oracle says, okay, we have too many of them, let's get rid of the old one and we create a new parent cursor. That's basically what it is happening here. Another question is, think about a scenario that session 1 has locked 5 rows. Okay, I will say it's going back to the row locking contention. I would say let's go to this question later on, because it's not really related to to what we are discussing here. Then there is one question: force match signature role in cursor. There is no role in cursor. Force match signature is just a mechanism that Oracle used to select SQL profile. It's unrelated with the cursor themselves, because the cursor are created based on a specific profile, but they are not related to two. Another question: whether the parent and child cursor are instance specific is RACDB. I'm not sure to understand the question. I mean, if you have a rack and you have several instances, the cursor exists on every instance. So you might have one parent cursor with 23 child on instance 1, and one parent cursor with 44 child cursor on instance 2, and the two are completely unrelated. So once an application connects to a database, remember what I said at the beginning, the ender points to a to a private SQL area that is attached to a server process on the server. Okay, and so you cannot share cursor between instances. The two are completely separated. Okay, so in the case of RAC, there is no relation between the different instances. Every instance will contain its own parent and child cursor. And last question, and then I will continue. If same table, if the same table structure is in different schema, one has an index, the other has no index, will use a different child. Yes, it will use a different child, but the point is it will not use a different child because the execution plane is different, but because the execution environment is not compatible. So Oracle, independently of whether one has an index or not, will create a different child cursor because the execution environment is not compatible. So let's continue with the next slides, because it's it's excellent. You have a lot of questions, but of course I also have to try to cover all the topics I planned. So bind variables. As mentioned before, you can share a parent cursor only if the text is the same, and in case you have values, of course, bind variable are important. Okay, but bind variable I have different, also impacts the application itself, not only the database. On the one hand, depending on which language you are using for writing your code, using bind variable can be easier or more difficult. It really depends on the situation. For example, if you are programming in PL SQL, it's easier to use bind variable. If you are programming in, I don't know, in Java with JDBC, it's easier to not use bind variables, for example. Okay, and from a performance point of view, bind variable introduce both advantages and disadvantages. Basically, the key advantage of using bind variable is that you are able to share cursor in the library cache, as we have seen before, and of course avoid parses and so on, which is very important for performance. But the disadvantage is that you kind of hide information from the query optimizer, because if the query optimizer has a bind, doesn't have a value, and the value is better to have a sound estimation. That's the reason why over time Oracle introduced bind picking. But bind picking is the what I will mention on the next slide. Before that, I would like to discuss bind variable graduation. What is bind variable graduation? Basically, for sharing a child cursor, the bind variables are important. They are part of the execution environment. So the type and the size, especially the size of the bind variables, matter. Let me show you an example that's, again, I think always better. So I create as always a small table called T, show you the character set, not very important in this case, just or what is important to note that here we have a single byte character set. Okay, we will see later on why. Now I execute the same insert statement with different values. Okay, as you can see, Helicon, Trantor, Calgan, and different integer here. And the variable n is a number, and the variable p it's a varchar 32. Okay, if we check the library cache, we get one child cursor that was executed 3 times. So the execution environment was considered compatible, so one child is enough. Now let's see what happens if I use a bind variable of 33 chars, 33 bytes instead of 32. Someone could say, well, it's exactly the same, so it's compatible. And also what happens if I have 128? I execute one time the to statement. And what we see, we have one additional child cursor with 2 execution. So in this case, Oracle determined that the 2 execution environments are not compatible because of the size of the bind variables. And we keep increasing the size of the variable. Now 129, 2000, we execute the 2. Again, we get a new child cursor. Even though, again, same execution, same statement, everything. But again, the size of the bind variables and their type is important. And if we execute even larger, and we stop at 4000 because it's the maximum here, we get a 4th child cursor. And the point is that, and that's called bind variable graduation, the size matters of the bind variable, and Oracle basically puts all the bind variable in, or parts the bind variable in 4 groups. One group is up to 32 bytes. Second group, 33 to 128. The third group, 129 to 2000, and more than 2000. Okay, and so part of the execution environment, you have this information. So as mentioned here, if you have one child cursor that was created on a bind with a maximum of 32 bytes, cannot be shared for another execution where the bind variable is larger. Okay. This is probably because Oracle internally has to reserve some space to exchange the values, and this space is, let's say, fixed in size and cannot be changed. Okay, so bind variable graduation is one typical reason why you can get a lot of child cursor if you have statements using like in the demo, strings that are of different size. Because think about the situation when you are 10, 15 bind variables, and these 10, 15 bind variables can have different sizes. Basically, you can have child cursor covering all the combination. So it's quite easy to get up to 1000 child cursor, for example, if you have a lot of combinations. Okay, that's a typical reason why we see a lot of child cursor on some systems, because they use a lot of bind variables, and the size of the bind variables is not always the same. Notice that if you want to inspect more in detail what a bind variable is, what happens in such situation, on the one hand, you can select $SQL shared cursor to see if the issue is due to what I just mentioned. As you can see, we see the flag set to yes for the child number 1, 2, and 3, by length upgradable. So that's the flag you have to look for. And if you want to look more in detail how a bind variable is defined for a specific child cursor, then you have to Sorry. Here is again more information about the reason for not being shareable. Here you can see bind mismatch and the maximum size of the binds. And then if you want to check more in detail the size of the bind variable, you can use $SQL bind metadata. And here for every child cursor, as you see here, you get information. I have 2 binds, one of type number, max length 22, one of varchar type varchar2, length 128. Okay, that's how you can analyze what's going on your system. So bind variable graduation is a very important topic, even though it's not frequently, let's say, discussed, but it's one common reason to have a lot of child cursors. Let me check. Okay, it's still the row log contention. Okay, now, as I was saying before, disadvantages of using bind variables, it's where bind peaking must be discussed. So to address the problem of replacing a bind variable with value, literal value with a bind variable, and the disadvantage for the optimizer, Oracle introduced bind peaking. And bind peaking is nothing else as to for the SQL engine to check what's the content of the bind variable before parsing a statement. And it gets the value, and so it can parse the statement as the bind variable didn't exist, if you want. Okay, because Oracle knows the value. And the problem with this approach, of course, is that if you have a child cursor that can be shared, okay, then you might end up sharing child cursor even though it's not efficient to do so. Let me show you an example. Bind variable peaking. Okay. Now I create a table T. Just notice that this table has basically a primary key. Okay, it's the ID, and this primary key contains all values going from all the integer values going from 1 up to 10,000. Okay, that's the content of the table. Now, if I execute this query and I say, just check how many rows I have with ID smaller than this number, we know, since we know that the maximum number is 10,000, that basically almost all rows will be accessed. Okay, and so if you check the execution plan, is not surprising that Oracle says, okay, if I access basically 99% of the rows, makes sense to use a full scan. Now, if I have a similar query, but this time I say IDs is lower than 42, I access just a small amount of rows. So in this case, the optimizer says, okay, index range scan on the primary key is fine, because I access just a bunch of rows. Okay, so that's fine, because as you can see, the optimizer can change execution plan based on the value. Now, if you use a bind variable, as I mentioned before, Oracle will pick the value of the bind variable. Okay, so in this case, it's 9,876. And based on this value, it will say full scan, because I expect to retrieve 99% of the rows. Okay, that's what we expect. But now the problem is that if I execute the same query, but now with 42, remember, based on all the rules I mentioned before about being able to share a child cursor, okay, in this case, Oracle says, yeah, I can share the parent, it's the same text. I can share the child, it's the same execution environment. So it will share the same child, so it will end up doing a full scan, even though an index range scan will be way more efficient in this case. But because of peaking and sharing, something like that is not possible. Okay. And that is where bind variable peaking is kind of problematic. And of course, the opposite can happen as well. I mean, if you start with a small value, okay, I get a... Okay, interesting. Why? I still get a full scan. I was sharing it for some reason. Sorry. I lost some information in my data. But the point of peaking, I obviously you saw, it's really a problem that's with bind variable and peaking, you improve sharing, also you increase the sharing, but sometimes you are sharing kind of too much if you want. So there is one new question. Will you provide a scripts test on your of course, if you want, I can share the script with the guys that organized it, and they will, I guess, put them somewhere that you can access, also download them. Yes. Now, bind variable peaking, something important to mention is that there are some limitations. For example, if you execute SQL statement through DBMS SQL, bind variable peaking is not supported. Okay, that's, I linked here the bug that mentions it. Notice that it's here is mentioned in a bug, but it's something that is known for, I would say, at least a decade, not more. Bind peaking is more than a decade that is available. So do not expect to see it fixed. Okay, so if you are using DBMS SQL, you have to know no bind peaking. That's how it is. Let me check the question. Okay, how about if add histogram on ID column? No difference whatsoever. So having histogram and so on is not something important for the optimizer for deciding if a child cursor can be shared or not. So it makes no difference in what I show you. And actually, maybe in my demo, did I add histograms? I don't remember how I collected the statistic. Let me check. I don't know, explicitly didn't get this one, but it makes no difference. So, and another question is the kind of logical, because DBMS SQL, you perform explicit SQL pass before assigning a value to the bind variables. Yes and no, it depends really how you do it. But the point is that it doesn't support it, and you must be aware of it. But you are right that depending how you, of course, write your stuff. The point is that also in a language, in other languages, you parse before, you can parse before setting bind variables. But what the Oracle driver, also the OCI driver, can do is to postpone the parse. So the parse is not executed when you execute the parse, is executed when you execute the execute. And so at the moment of the execute, everything is known. So Oracle had to change the way that also the drivers communicate to the engine because of that. Okay, so it's not only a reason of when you set the bind variable and so on, but they have to change it. And since they say DBMS SQL is not critical, we have dynamic SQL statement, PL SQL, and that's the way to go. If a value is much greater, it should have created a different child cursor. Why is this using the same child cursor? No, it won't create a new child cursor. As I mentioned before, all estimation whatsoever, it's not important, because if Oracle can share a cursor, it will share it. It won't check, well, maybe the execution plan can change and so on. Now, if it's shareable, it will share it. It doesn't matter everything else doesn't matter really, except in a case where that I will discuss in a moment. What is the number of open cursor issues? Open cursor is just a maximum that you can set. That is, for every session, you have a maximum number of open cursor. It's not really an issue. I mean, it's a parameter you can configure. And in general, we try to keep that low because, of course, if you have a lot of child cursor or a lot of cursor open, then you will have a lot of memory allocated at different layers. So it's better to keep the number low. But if you need more cursor, you can create them if you have the memory. How we can take care of it? I'm sorry, I don't understand what you're referring to. Okay. Good. Let's continue with the next slide because it's it's time to finish here. So you just saw the problem with bind picking, and to try to solve or work around this problem, Oracle implemented adaptive cursor sharing. The idea of adaptive cursor sharing is to recognize when bind picking is a problem and to automatically adapt to the situation. Let me show you a demo about it to explain you what is all about adaptive cursor sharing. So the beginning of this demonstration is exactly the same as I showed you before in bind picking. Okay, it's the same table, I have the same queries. Oh, sorry, here something went away of the library cache. So it's the same query, everything exactly the same. Now, what I wanted to show you is that if I execute this statement with 42, I have an index scan, fine. I execute it with now 9,000, I get an index scan as discussed before. But now what happens? Here you see I have only one child cursor. Okay. Now what happens if I keep executing this query with the value 9,000? And what you see now is that the system changed the execution plan. How that's possible? I mean, I said before, if something is shareable, it will be shared. The point is that Oracle, and if I execute now with 42, it will use an index scan. So we end up with 3 child cursor. One was obsoleted, is no longer shareable, is the first. And then we have 2 additional child cursor. So what happened here? Basically what happened is that Oracle, for the first child cursor, set this flag, which is bind sensitive. That means Oracle is aware that bind picking is used and that bind picking can be a problem. And so tells the SQL engine, keep an eye on this cursor. If I execute it with values which are completely different, that leads to inefficient execution, it's not good. I want to automatically fix this issue. Okay, and that's what happened here. Basically, I executed several times the cursor with the 9,000 value, which is bad in this case, and Oracle automatically detected the issue. So it made the first child cursor unshareable, created a new one, but this time it said the cursor is bind aware. And what bind aware means that Oracle will check before selecting a child cursor, which is the bind value I'm using. If I'm using the first 42 we have seen before, it will use the index scan, which is this one. And if I use the 9,000 value, we'll use the full scan, which is the second one. Okay. Of course, it doesn't store every single value because it would be overkill. What they store, what Oracle will associate to every child cursor, let me show that, is a selectivity estimate. It says use child cursor number 1 if the selectivity is close to 1. Use child cursor number 2 if the selectivity is close to 0. What you can imagine is that when a statement is executed, picking always takes place, and depending on the value that picking returns, Oracle calculates the selectivity and then says, okay, I use this one or this one. Or if I am in the middle, Oracle will create a new child cursor. And with this adaptive cursor sharing, Oracle can recognize problem automatically. Your demo goes on and on, but we have no time to look at that in detail. So adaptive cursor sharing is a way to automatically recognize situation caused by bind picking. Works well in some situation, but I would say not always. But when it works, again, it will invalidate a child cursor and create a new one. Notice that if it doesn't work well, you have a couple of things you can do. For example, you can force bind awareness with the int bind aware. That means that Oracle doesn't have to learn that the statement has a problem with bind picking. You put the int in, and then Oracle will immediately create the cursor bind aware. In that way, from the start, you get, let's say, the good execution plan, hopefully. And if you don't want to do it or if you do not have to do it for a single SQL statement, you can also do it at session or system level with this parameter, optimizer adaptive cursor sharing, and you have to set it to false. Then all cursor will be set to bind away. So adaptive cursor sharing is something really interesting when you deal with bind variables picking problem. Let me just check question. How we keep track of bind variable used in application by the same child cursor? Basically, you can't. As I mentioned one time before, you can only enable SQL trace, then you get all the values, but otherwise you cannot really keep track of them. And as I mentioned, if you are talking about the adaptive cursor sharing, the point is that it won't track every bind variable, but only the selectivity associated to it. And so they managed to summarize in a very compact way a lot of information. Okay. Just a slide to mention a couple of limitations of adaptive cursor sharing. Notice that it doesn't work if you have many bind variables. So if you have more than a dozen of them, it's not working. Be careful that it can only take place during parse calls. So if you're not parsing, adaptive cursor sharing will not take place. That means if you keep cursors open and you execute them many times, then you keep the plan of the first parse. Okay. So the SQL engine is only able to create new child if you if you parse a statement, which is of course not so good, because as I mentioned before, it would be good to share cursor, but sometimes, yeah, it's probably too much. And be careful that also the PL SQL engine, this limitation applies also to the PL SQL engine. That means that PL SQL engine tries to keep cursor open as much as possible, and so the PL SQL engine adaptive cursor sharing doesn't work as you might expect. And again, since picking is not possible, also adaptive cursor sharing is not supported by the DMS SQL. Okay. Last feature I wanted to cover in this session is statistics feedback. And statistic feedback is another of this feature that can kick in and basically change the execution environment, a bit like the adaptive cursor sharing does. Okay, but yeah. What is statistic feedback? Basically, the idea is that with all the query optimizer statistics which are stored in the data dictionary, Oracle is not always able to generate efficient execution plan. And that's because it's not able to estimate correct cardinalities. Of course, it can also use stuff like dynamic sampling in some situation, but not all cases are covered. Okay, so with statistic feedback, Oracle introduced a feature where basically cardinalities can be estimated based on previous execution. Think about your executing a statement 2 times. The first execution, you go with an estimate which is not very good. Then during the execution, the SQL engine can learn something. What is the real number of rows that are processed? And then keeps this information as a feedback, how they call them, and use the information to produce a new child cursor. Okay, so that's a feature, again, that's like adaptive cursor sharing that you can take advantage of if you're executing a query several times. And basically what happens is really that if such a feedback is generated, like in adaptive cursor sharing, the old child cursor is invalidated, a new one is created, and the new one maybe gets a better execution plan. Okay. Also in this case, let's have a look to a demo. Okay. Now to have a simple demo about statistic feedback, I take a special case, but what I wanted to point out is just here, the demo is easy and reproducible, but this kind of stuff happens independently of what I show you now, specifically of the use of table function. Here what I create is a function, as you can see, it's a pipeline, table function, and the table function takes as input an integer value, okay, and basically produce so many rows as this value. If I say here 10, I will have the rows containing value 1, 2, 3, up to 10 as an output. Okay, that's the idea. This is not relevant here. Let's put it through. It's not relevant. Okay. Now, how I use this function is that I want to join the output of the function with a table. Okay. Now, in this case, we know that here 10 rows are generated, but in fact, the optimizer has no clue at all about such an information. Okay. If we check the execution plan that is generated for this statement, what we see, let me go back, is that Oracle say, okay, let's take 8,000 rows. Why 8,000? Simply because it's the block size of this database. No idea why they use that, but it's the way it works. But they say, okay, I will join 8,000 rows with 10,000 rows. Okay, that's the estimation. But at the same time, Oracle knows that was just a value that is not even an estimate, it's just a value that I took from somewhere. So what happened is that this child cursor was marked and to say to the SQL engine, when you execute it, please check this value because I have no clue what this value is. And if you check the display cursor outputs with the value, the format report, what you can see later on here, you can see, this cursor is marked for automatic re-optimization. And they say, okay, I executed, if I re-execute, I executed it. If I re-execute it, instead of using this child cursor, I will use, or this plan, sorry, I will use this one. Okay, and the estimation is completely different. Now it's much more closer to the reality. And if I go back, remember I executed the statement only one time. I just executed it, first execution. I checked the SQL ID and I generated this report. Okay, so in this case, the database engine automatically detected that this estimation is completely wrong, produce a feedback and say if you re-execute it, you get this one. So if now we check the content of $SQL, we can see we have only one child cursor, which is shareable, but is also marked as re-optimizable. So if we check $SQL, the re-optimization int, we see what kind of information the feedback contains. And basically it says if I select, if I do an access to this function, which is called like that here, estimate 20 rows, not 8,000. So if I execute the query an additional time, a second time, now I get the expected execution plan with the new estimation. And in the note, you also see statistic feedback used for this statement. Okay. And if we check the status of the child cursor, you can see that the old one is no longer shareable. It was invalidated, basically, and a new one exists. And the one is not re-optimizable. Okay. So this is how statistic feedback works. In SQL share cursor, you can see these cases with this flag use feedback stats. As you can see here, well, it was set to yes. Okay. So this was statistic feedback. Again, one reason why sometimes stuff get automatically invalidated and new child cursor created. Just a few comments about the configuration of statistic feedback. Notice that in 11.2 and 12.1, by default, it is enabled. Okay, so it kicks in by default. Here are the parameters that controls it if you want to change this behavior. In 12.2 and later, it's partially enabled. That means it kicks in for single table cardinalities misestimate like the one I showed you, but not for joint cardinalities. So if you want to completely activate the feature in 12.2 plus, you have to set optimizer adaptive statistic to true. Okay, it's a bit strange how the configuration is done, but it's the way it is. And by the way, this is a link to the Moss note that explains how to backport the 12.2 configuration to 12.1 in case you want to do it. Okay, that was the last slide I prepared that I wanted to show you, but I see there is one additional question. Let me take it. When will we have troubleshooting our performance next edition covering 19C? Okay, that's its question that is unrelated, but I'm happy to answer it. Actually, I'm working on it right now. I cannot give you a date. My hope is to have the first draft by the end of the year. That means that sometime next spring, it's possible. I cannot say for sure, but that's what I would love to do. And how to completely turn off statistic feedback in 12.2 if you want to. Basically, what you can do is, let me go to slides. The optimizer use feedback parameters as is provided here is still available. So if you set it to false, you will deactivate it. But if you want to a more in-depth discussion of the different parameters in this area, I have a blog post about it. Check it on my blog. It's few years old, but I have all the undocumented parameters related to adaptive features. So refer to it and you will get a number of information how which parameter exists and which one to set for what reason. So in summary, since we are already 5 minutes over time, let's summarize, in my opinion, the most important information I share with you today. First, if you want to share, or if the system wants to share a parent cursor, the text of the SQL statement must match exactly. Okay. As you've seen, there is an exception if you set cursor sharing, but except from that, the text must be the same. If you want to share a child cursor, there are many criteria. Okay, that have to be fulfilled, but remember, it's nothing related to basically to the execution plan itself. Is more the execution environment must be compatible and the parent cursor must be shareable. Okay, bind variables are not always good. Be careful. I say bind variables are essential in many situations, But what I want to point out is that there are also issues with them. So in some specific situation, it might be interesting to not use the bind variable. But in general, use them, it's good. But you have to be aware that there are situations where they are not good. Keeping cursor open is again one thing that we always advise to do. But again, there are situations that is not good. So again, keep cursor open most of the time. It's fine, but not always. In general, every time somebody says always do that or never do that, it's false. Okay, there are always corner cases where it won't be true. Okay, and also because of adaptive cursor sharing and statistic feedback, be careful. Every statement which is parsed more than one time basically can get a different execution plan. Okay, do not expect, because you change nothing from kind of your side, that the SQL engine doesn't come up with some new optimization. So adaptive cursor sharing and statistic feedback are a good example where the instance tries to learn something automatically out of your workload. Okay, so that was as I prepared for today. I don't know if there are additional questions. I see a new question on how to check cursor is closed or how to close cursor. I mean, if you want to check whether a cursor is closed, basically you have to, for example, you have the view $open cursor. Okay, that tells you which cursor are kept open for which session. Okay, that gives you an idea what is open right now and who has the cursor open. That is very important. How to close the cursor? The problem, only the application can close it. Okay, of course you can kill the session and then we'll close the cursor. But otherwise, only the application has the control of the cursor. So it's the application that opens the cursor, it's the application that closes the cursor. Okay, that's the way it is. Okay, I see only. Okay, just thanks. Thank you. So since there are no longer other questions, let me get back to these row locking contention questions that are, as I mentioned before, not related to what we were discussing it, but I mean, I have time to think about scenario when one session locks. We're live. A second. One session locked 5 rows in 5 different tables. Session 2 is trying to lock first table row of session 1. How do we find out which is the SQL session 1 executed with row is locked? Okay, so you are saying you have 2 sessions. The first one changes and locks some rows, and then does some work, okay? And then later on, session 2 changes one of these, also try to change one of the row, but no longer get a lock, but you want to know which is the statement that executed it. So basically, since session 1 can execute plenty of stuff after setting the lock, you cannot directly get this information out of directly from TSG. But what you can do in this case, I think I have a blog post about it. Let me just quickly check. I'm pretty sure I have a blog post because I had this problem once. Let me see, category. Okay, that's the blog post, which is, again, rather old, 2012. But it describes basically what you want. You have a row lock contention. Let Let me make it bigger. You have a rollout contention. Okay, this session waits on the other one. The other one is doing nothing, and you want to know what this session did. Okay, and I had such a case for a customer, and the only way we found to extract that information was to use the log miner. So it was about identifying the transaction ID, what is called the XID of the first session, then to check in the archived redo logs based on the SCN, which redo log or archived redo log contains that SCN. And then we just, in this case, load the log miner with the statement you see here. And then you can simply select with all the log miner contents with the transaction ID identified before, and then you get the statement out of this thing. So let me put I will put this how I can sorry. Let me put the link in the. I can put the link.
Christian, you can put it in the chat window. I think.
Yes. But where is the chat? Want to put it in there.
So on the top bar, your sharing
screen
bar. At the last,
I set it in the first answer. It goes as well. So that's it. The other is good. Please share the link. Okay, I will type the answer here as well, so you do not have to search for it. Okay, thank you. So based on that, somebody asked the inactive session blocks another session. What is the reason and solution? The reason is that the inactive session didn't issue a commit. Why, you don't know. It's simply that the session didn't issue the commit. The session is still there because the connection is open. So you don't know why. The solution is basically check the application and understand why it didn't commit. And depending on what you found, fix it. But basically it's an application problem because the commit can only be executed by the application. Anything else is not possible. Another question: if statistic feedback and an adaptive cursor sharing enabled, will the plan change even if SQL has SQL plan baselines? Okay. I mean, adaptive cursor sharing and SQL plan baseline or statistic feedback can work together because what you can expect or what you have to imagine is that if you have a baseline that contains several accepted plans, one, for example, if I go back to my demo of before, one with a full scan, one with an index scan, okay, both plans can be accepted and be part of a SQL plan baseline. And now you have to be able to select them. And so, yes, they will work and work together. It will be a bit kind of mess because all the features work together. But the idea is that when the feedback will be used, it will provide the SQL Auto Optimizer the ability to select one baseline. If maybe the feedback is not used, it's another baseline that will be used. So in any case, absolutely, they will work together and is by design, and it's good. So, okay, I went through all the questions. I think we are done. From my side, all I can say, it was a pleasure to share some knowledge with you. Thank you very much for attending. If you have more questions, I put my email address in on the slides, so you are able to write to me or use my Twitter handle. And the only thing that is remaining, I will share the scripts I use with the organizers, and then I guess they will put them where they put the slides. It's right?
That's correct.
Okay, excellent. So again, thank you very much, everyone. Bye-bye.
Thank you so much, Chris, again, for your time, for the great session that you just gave us, for all the information that you shared. We really appreciate it. Before Chris leaves, I mean, as you can see on your screen, you can see a speaker feedback QR code. Just scan this QR code and you can provide your feedback. As Chris mentioned, if you have any more questions, you can use this to share or relay the information. Post in your questions, and we'll share the feedback with Chris. And as Chris mentioned, we'll get across all the information that he wants to share with you. And all this would be put up in our on our portal, AIOUG portal, and you can access the presentation as well as the scripts and all the information that Chris will provide. Again, I would like to request you to take a moment of your time and head over to Twitter, Facebook, or LinkedIn and thank Chris for his time. I mean, in this virtual webinar, that's perhaps the only way we can thank Chris. Another thing I wanted to share was, again, please send your email IDs to webinar@aioug.org. And this is in case you want the participation certificate. So this is the email ID. And now, before we close, we just wanted to give you a glance at all the exciting sessions that are coming up. First up, we've got the MySQL session that's coming up soon this weekend. So we are actually starting a special interest group on MySQL. That's what we are planning to do, or that is one of the special interest groups that we are thinking of. And we encourage you to join the first MySQL session from the MySQL team. We are also planning to host one exclusive event in September. We will share the details, and you can watch the space on our AIOUG website for further details. Now that the whole day event will include live demos, performance tuning sessions, and a lot of things. So we are still planning, and we will share the details about the September exclusive event later. But right now we do have a MySQL session. So the MySQL would, excuse me, would be coming up soon. So if you have not already registered, do register. And then we have some more exciting sessions about table scans for DBAs by Roger. Then we've got Maria with us, who'll be talking about explain plans. And then, of course, we've got Rob, who'll be here to talk about database security on cloud. So I hope we see you again in the upcoming weeks. We've got a packed month ahead. So hope to see you then. Everybody have a great day, and thank you for joining.